Biomedical waste management is a critical discipline within the healthcare sector, focusing on the systematic handling of waste generated during medical activities. This presentation provides a comprehensive guide to the protocols and systems used to manage hazardous materials effectively. We will explore the vital importance of protecting healthcare workers, patients, and the environment through rigorous waste handling standards. By understanding these principles, medical institutions can ensure safety, maintain legal compliance, and contribute to global public health goals. Every step in this process is designed to minimize risk and maximize the efficiency of waste disposal and recycling. Categorization and segregation protocols represent the foundational pillar of the waste management lifecycle. This specific section, identified as Lesson 4, focuses on the systematic methods used to divide waste into distinct groups based on their properties and risks. Proper categorization ensures that each type of waste receives the appropriate treatment, preventing cross-contamination and environmental hazards. Segregation protocols are the practical steps taken to implement this categorization at the source. Understanding these protocols is essential for any healthcare professional to ensure that the entire waste management chain remains functional and safe for everyone involved in the process. Point of generation priority is the most critical rule in waste management, stating that waste must be sorted immediately upon generation by the attending clinician or nurse. This means the person performing the medical procedure is responsible for placing items in the correct bins. The second key concept is that downstream technology is useless if initial segregation fails at the bedside. Even the most advanced treatment plants cannot fix the problem if hazardous needles are mixed with general trash or recyclables at the start. Therefore, the success of the entire system depends entirely on the accuracy and diligence of the staff at the exact moment the waste is created. The four-color Indian system is a pragmatic behavioral approach utilizing yellow, red, white, and blue containers to simplify the sorting process for staff. This system is designed to be intuitive, reducing the cognitive load on healthcare workers during high-stress situations. Additionally, this system focuses on the required treatment method, rather than complex biological taxonomy. Instead of requiring staff to identify the specific biological nature of a pathogen, they only need to know how the item should be treated, whether it needs to be burned, sterilized, or recycled. This practical focus ensures higher compliance and significantly reduces the margin for error in busy clinical environments. The yellow category is specifically designated for items requiring thermal destruction. This category is reserved for human anatomical waste, soiled cotton, expired medicines, and chemicals that pose a significant biological or chemical risk. Because these materials are highly hazardous, the protocol requires complete high-temperature destruction via incineration or plasma pyrolysis. Incineration uses extreme heat to reduce organic matter to ash, while plasma pyrolysis uses ionized gas to break down molecules. These methods ensure that all pathogens and toxic chemical structures are completely destroyed, preventing any possibility of environmental contamination or the spread of infectious diseases from these specific waste types. The red category is dedicated to recyclable plastics and handles materials that can be safely reused after intensive processing. This includes contaminated plastics, like IV tubes, syringes without needles, and catheters that have been in contact with patients. The mandatory protocol for these items is that they must be autoclaved to sterilize pathogens, then shredded and recycled. Autoclaving uses high-pressure steam to kill all microorganisms, making the plastic safe to handle. Once sterilized, the plastic is shredded into small pieces to ensure it cannot be reused in its original form, eventually being processed into new plastic products to support sustainability. The white category is strictly for sharps and utilizes specialized containers to ensure safety. These are translucent, puncture-proof, and tamper-proof containers designed to prevent accidental needle sticks. The category is dedicated exclusively to metals, needles, and scalpels to prevent occupational injuries among healthcare and waste workers. By using translucent walls, staff can see when the container is full without opening it. The puncture-proof material is a vital safety feature that ensures sharp metal objects cannot pierce the sides, while the tamper-proof lid ensures that once the sharps are inside, they cannot be easily removed or spilled during transport. The blue category is for glass and implants and employs specific storage requirements for these heavy or fragile items. It utilizes puncture-proof boxes with blue markings for broken glassware and metallic implants that have been surgically removed. Because these items often carry biological loads, the protocol requires chemical disinfection or autoclaving prior to recycling. Chemical disinfection involves soaking the items in a strong disinfectant solution to neutralize pathogens. Once the glass or metal is rendered non-infectious, it can be sent to specialized recycling facilities where the materials are melted down and repurposed, keeping these non-biodegradable materials out of landfills. Global harmonization on plastics reflects a unified effort to improve environmental safety standards. Both WHO and Indian authorities prioritize keeping PVC out of incinerators as a primary safety goal. Polyvinyl chloride, or PVC, is common in medical tubing, but releases toxic gases when burned. This strategy protects local communities from respiratory hazards and carcinogenic fallout, such as dioxins and furans, which are produced during the combustion of chlorinated plastics. By aligning Indian protocols with World Health Organization guidelines, the system ensures that the air quality surrounding treatment facilities is maintained and that the long-term health of the public is prioritized over simple disposal methods. Economic value recovery is a significant benefit of a well-organized waste system. Proper red bin segregation ensures high-grade medical plastics re-enter the circular economy rather than being wasted. Medical plastics are often made of high-quality polymers that are very valuable if kept clean and separate. Furthermore, recycling generates revenue for treatment plants and reduces virgin plastic consumption. By selling the sterilized, shredded plastic to manufacturers, treatment facilities can offset their operating costs. This creates a sustainable financial model that rewards hospitals for accurate segregation and reduces the overall environmental footprint of the healthcare industry by decreasing the need for new plastic production. Thank you for completing this lesson on categorization and segregation protocols. We have covered the critical importance of point-of-generation sorting, the specific functions of the four-color coding system, and the environmental and economic benefits of proper waste management. Adhering to these standards is not just a regulatory requirement. It is a fundamental commitment to the safety of our healthcare workers, our patients, and the global environment. By applying these protocols diligently every day, you play a vital role in the success of the medical waste lifecycle. Thank you for your time and your dedication to maintaining these essential safety standards in your professional practice.